We're going to take a look at VSEPR shapes here. Your focus should be on ones that follow the octet rule. However, you should have an understanding of ones that do violate the octet rule. Draw the VSEPR diagram and include labels for angles for the carbonate ion. So the carbonate ion, when we draw its Lewis dot diagram, has a carbon in the middle, double bonded to an oxygen, to another oxygen, to another oxygen. Alright, and this is a 2- ion. When we're looking at the carbon has 1, 2, 3 bonds to it. So we can write its general formula as AX3. There are no lone pairs on our central atom, carbon. They're on the outer atoms, but that doesn't affect our VSEPR shape. So the general formula for the carbonate ion will just be AX3. When it is AX3, that means that it is trigonal planar. Planar meaning that it's flat. It can lay flat in your hand if you were to build it with the model set. So around the carbon, 3 oxygens, 1 is double bonded, and between each oxygen is 120 degrees exactly. Because it's flat, we have everything in a circle. 360 degrees is available, and we can divide that by 3. Next, we're going to draw the VSEPR diagram for Nh3 Ammonia. When we draw ammonia, we get N with a lone pair to 3 H's. With this, we have 1 lone pair and 3 bonded atoms, giving us the trigonal pyramidal shape. So with trigonal pyramidal, this is making a triangle on the bottom where all of the H's are like a pyramid. So if we were to draw this, we have to draw it in 3D because the lone pair occupies quite a bit of space up top. We have one H sort of pointing down, the other one coming out towards us, and one going into the page like we would draw a tetrahedral. And between each of these, tetrahedral is 109.5, but because we have this lone pair up top here, it takes up a little bit more room, pushing these guys closer together, and we get 107.3 degrees. Lastly, let's draw the VSEPR diagram and including labels of angles for PF5. So PF5, we're going to put phosphorus in the middle and 5 fluorines around it. So with this, we had 5 plus 5 times 7 electrons, which gives us 40. We've used up 10 already, so we're left with 30. And we put them around the phosphorus, or sorry, the fluorines. And we are out of electrons. So around the phosphorus, we have AX5, and there are no lone pairs. AX5 is trigonal bipyramidal. And this is all of our different shapes that have trigonal in their name. When we draw our shape, we get phosphorus in the middle, and we get 1 fluorine up top and 1 fluorine around the bottom. And then we get 3 around the middle in a planar fashion. Okay, so we draw 1 out and 1 in the page for ourselves. The angles between these phosphoruses is 120. Alright, the angle between these ones is 180, and the angle between the top and the middle, or the bottom and the middle, is 90 degrees. So that's all you need to know about VSEPR shapes. There are quite a few when we go past the octet rule into the octahedral family. However, like I said, your focus should be up to the end of the tetrahedral family, so including trigonal pyramidal and bent AX2E2.